Hello everyone, hope you're feeling good. I am glad to be with you in this lecture and the wonderful students. Today I will talk in my lecture in operating systems course lectures for fourth level students. Chapter 1, Introduction. What operating system do? Computer system organizations, computer system architectures, operating system structure, operating system operation, process management, memory management, storage management, protection and security, kernel data structures, computing environments, open source operating system. Objective: they describe the basic organization of computer system. Number 2, to provide a grand tour of the major component of operating system. Number 3, to give an overview of the many types of computing environments. Number 4, to explore several open source operating systems. What is an operating system? Operating system is a program that acts as an intermediary between a user of computer and the computer hardware. Number 2, operating system goals. Executive user programs and make solving user problems either make the computer system convenient to use the computer hardware in an efficient manner. Computer system structure. Computer system can be divided into 4 components. Hardware provides basic computing resource. CPU, memory, input and output devices. Operating system controls and coordinates user hardware among various applications and users. Application programs define the ways in which the system resources are used to solve the computing problems of the users. Word processor, compilers, web browsers, database system, video games. Number 4, users, people, machines, other computers. 4 components of a computer system from user, the graph or this image explain the 4 components of the computer system. From user 1 to user n, compiler, assembler, text editor. User 1 represent compiler, user 2 between user 2 and assembler, text editor, database system, system and applications program, operating system, computer hardware. the four components of the computer system. What operating system do depends on the point of view. Number two, users want convenience, ease of use, and good performance. Don't care about resource utilization. But shared computers such as mainframe or main computer must keep all users happy. Number four, users of dedicated systems such that workstation have dedicated resources but frequently use shared resources from servers. Handled computers are resource poor, optimized for usability and battery life. Some computers have little or no user interface, such as embedded computers in devices and automobiles. Operating system is a resource allocator. Manage all resources, decides between conflicting requests for efficient and fair resource use. Operating system is a control program. Operating system is a resource allocator. Operating system is a control program. Controls execution of programs to prevent errors and improper use of the computer. Operating system definition. No universally accepted definition. Everything a vendor shapes when you order an operating system is a good approximation, but virus world. The one program running at all times on the computer is the kernel. Everything else is either a system program ships with the operating system or an application program. What is a kernel? Computer startup. Boot startup program is loaded at a power up or reboot, typically stored in ROM or EEPROM, generally known as firmware or analyzes all aspects of system. Loads operating system kernel and starts execution. Computer system organization. Computer system operating one or more CPUs, device controllers, connect through common bus, providing access to shared memory. Concurrent execution of CPUs and devices computing for memory cycles. This is the CPU, disk controller or disks, disk, mouse, USB controller, memory, keyboard, mouse, printer, monitor, graphics adapter. This is a computer system organization. Computer system operating output, input and output devices and the CPU can execute concurrently. Each device controller is in charge of practical device type. Each device controller has a local buffer. CPU moves data to main memory from local buffers. Inputs and outputs is from the device to local buffer of controller. Device controller informs CPU that it has finished its operating by causing an interrupt. Common functions of interrupts. Interrupt transfer control to the interrupt service. Routing generally through the interrupt vector, which contained the addresses of all the service routing. Interrupt architecture must save the addresses of the interrupted instruction. A trap or expectation is a software generalized interrupt caused either by an error or user request. An operating system is interrupt driven. Interrupt handling. The operating system preserves the state of the CPU by storing registers and the program counter. Determines which type of interrupt has occurred, boiling a vectorized or interrupt system. Separate segment of code determine what action should be taken for each type of interrupt. Interrupt timeline, CPU, input and output device. This output and the input request transfer done and implies to inputs and output request transfer done using the process executing. Input and output interrupt processing transferring. This is the interrupt timeline. Input output structure. After input and output starts, control returns to user program only icon. Inputs and output completion. Wait instruction idle the CPU until the next interrupt. Wait loop connection for memory access. At most one input or the abbreviation input and output request is the outstanding at a time, no simulation. Inputs output processing. After input output starts, controller returns to user program without waiting for and or completion. System call request to the OS operating system to allow user the wait for I and O completion. Device states table contains entry for each inputs and output device inducting its type, addresses, and state. Operating system indexes into inputs output device table to determine device states and to modify table entry to include interrupt. A storage definition and notation review. The basic unit of computer storage is the bit. A bit can contain one of two values, 0 and 1. All other storage in a computer is based on collection of bits. Given enough bits, it is amazing how many things a computer can represent. Numbers, letters, image, movies, sounds, the commands and programs. To name a few, a byte is 8 bits, and on most computers it is the smallest convenient a chunk of storage. For example, most computers don't have an instructions to move a bit, but do have one to move a byte. A less common term is word, which is a given computer architecture's native unit of data. A word is made up of one or more bytes. For example, a computer that has 64-bit registers and 64-bit memory addressing typically has 64 bits or 8 bytes words. A computer executes many operations in its native word size rather than a byte at a time. Computer storage, along with most computer throughput, in generally measured and mean in bytes and collection of bytes. Kilobytes or kilobytes in abbreviation kilobyte is 1024 bytes. A megabyte or megabyte is 1024. Power 2 bytes. A gigabyte or gigabyte is 1024 of the power to 3 bytes. A 3 byte or TB is 1024 power 4 bytes. Petabytes or PB is 1024 of the power to 5 bytes. Computer manufacturers often round off these numbers and say that a megabyte is 1 million bytes and gigabyte is 1 billion bytes. Networking measurements are an exception to this general rule. They are given in bits because networks move data a bit at a time.